Bubble sort. Bubble sort is a simple sorting algorithm that works by repeatedly swapping the adjacent elements whenever the adjacent elements are not in the right order. So let us understand how this works. If you have an array like this and you are scanning through the array in order to sort the array, what will happen? Whenever you find adjacent elements, any two adjacent elements that are not in the right order, what will you do? You will swap them. That is, if you are sorting in ascending order and you find out that whatever is there on the left side that is larger and whatever is there on the right side that is smaller, that means these two elements are not following ascending order. What do? You swap these two elements. Whatever was there on the right side, you will put it on the left. Whatever was there on the left side, you will put it on the right. So this is what you will do. And you will continue this process from one end of the array till the other end of the array. And what happens when you reach the other end of the array? You call it as one pass. That is, whenever you complete this process once from one end of the array till the other end of the array, you will say one pass is completed. So at the end of your first pass, what happens? One element will be placed at the correct position. And which is that element? Which is that element that will be placed at the correct position? Whichever is the largest element in this array, that will be placed at the last position. So one element will be placed at correct position. And how will this largest element be placed at the correct position? See, it works like this. What are you doing? You are going to start from here. You are going to compare and understand whichever is larger. So you will compare first two positions. Whichever is the largest element among these two, you will place it in the rightmost position. This you understood? What is the next step? You will compare next two positions. Again, you are going to do same comparison and you are going to swap. When you swap, what happens? Whichever is the largest element, that will be placed at the rightmost position. Till the point you have considered, at the rightmost position, you will have the largest element. You will continue this process to the next two. Again, whichever is the largest, that will be at the rightmost position. You will continue this process till you reach the end of the array. And whenever you reach the end of the array, what happens? Among the complete array, whichever is the largest element, that will be placed at this position. So at the end of first pass, you know that last element is already correct. You don't have to consider it again. So in the second pass, you are going to only consider this much of the array. You are not going to consider the last element again. And what happens at the end of second pass? Whichever is the second largest element in your array, that will be placed at the correct position. So whenever you go to the third pass, you don't have to consider last two positions because whatever be the number of passes you have completed, that many elements will be already placed at the correct position. That too, that many largest elements. Okay. So in each pass, what happens is whichever is the largest element in the remaining set of array, that will be placed at the correct position. So this is what bubble sort does. We'll understand this with an example. Then it will be very clear for you. So we'll take an example. This is my example array. Elements are 42, 70, 12, 30 and 24. These are my elements. So I am going to perform bubble sort on this array. Let us see how it works. What is the first thing I have to do? In my first pass, I have to start comparing from the left end of the array. So I'll compare first two elements. Which is the larger? 70 is larger and it is correctly placed on the right side. So I don't have to do anything here. I'll move on to the next two elements. What about the next two elements? 12 is the smaller among these two elements, but 12 is placed on the right side, which means I have to swap 12 with 70. So I'll swap here. 12 will come on the left side, 70 will come on the right side. What is the next step? I have to compare 70 with 30. The same thing happens. 30 is smaller than 70 but still placed on the right side, which means I have to swap. So I'll swap. 30 will come on the left side, 70 will go to the right side. Next step, I'll compare 70 with 24. Again a swap happens. 24 comes to the left side, 70 goes to the right side. So at this point, I have reached the end of the array and see what happened. 70, which is the largest element of the array, is now rightly placed at the last position. So in the next swap, next pass, I have to compare only till this point. Okay. So we'll go to the second pass. In second pass, what happens? I'll compare 42 with 12. 12 is smaller, so 12 comes to the left side. 42 goes to the right side. When I compare 42 with 30, 30 is smaller, 30 comes to the left side, 42 goes to the right side. What happens when I compare 42 with 24? Again, the same thing happens. 24 is smaller, it comes to the left side, and 42 goes to the right side. So at this point, I don't have to compare 70 again because after first pass, largest element is already at the correct position. So my second pass is completed now, and what happened? My second largest element, 42, is also placed in the right position. So my two elements are now placed in the right position. I'll progress to the third pass. What happens in third pass? When you compare 12 and 30, they are in correct positions, so nothing to be done. What is the next step? You go to next two elements, 30 and 24. So these are not in the right positions, so you have to swap 24 with 30. So at this point, my third pass is also done and my third largest element is also placed in the correct position. I'll progress to the fourth pass. In the fourth pass, when I compare 12 with 24, they are already in the correct position. I don't have to do any swap. So in bubble sort, one thing that we do additionally is whenever we do a complete pass without any swaps, that means whatever is there in the unsorted position of the array, unsorted part of the array, that is already in sorted order, because that is why you didn't do even a single swap. You also know that whatever is in the sorted part of the array, that is already in correct positions. So whenever you have one pass without any swaps, you can stop it. That is what you follow in bubble sort. So your stopping conditions are two. One is that whenever you have a pass without any swaps, you can stop or if you completed the complete array, then also you can stop. That is, in first pass, you checked complete array. Second pass, you check n-1 elements. Third pass, you check n-2 elements. And whenever you have a pass in which there are only two elements, you can automatically stop. So this is how bubble sort works. So what we'll do is, we'll write the pseudocode and let us understand the time complexity and space complexity of the algorithm. And one more thing, why is this called as the bubble sort? Why the name bubble sort for this algorithm? Because what happens to bubbles in water? Bubbles will always come up in water. This is what you normally see. Whenever you see bubbles in water, they'll come up in the water. So in this particular case, it is called bubble sort because whatever is the other larger elements, they'll bubble up to the top of the array. That is why you call it as bubble sort. After each pass, one larger element will bubble up to the top of the array. So that is where the name bubble sort comes from. Let us write the pseudocode and understand. So in order to write pseudocode, you should have logic clear in your mind. What is the logic you are going to write? You should have one loop. What will this loop do? It will go from 0 till n-1, that is whatever is the last element. And in a second loop, what should you do? The first loop says this is my pass 1, this is my pass 2. So this is for counting the passes. Whatever is the first loop, that is for counting the passes. What is the second loop going to do? Second loop is going to do the operation inside each pass. So one loop for counting the passes and the second loop which is inside, whenever you get inside a pass, whatever you have to do. So that these two loops are what we are going to have in this bubble sort algorithm. So let us write the pseudocode and understand, that's better. Bubble sort. You want to sort array, okay? You have an input array which you want to sort. What will you do? You have n is the length of your array. So you are finding the length of array and calling it n. Next thing is you have to start the loop. So your first loop is for counting the passes. So you are counting passes from, let us say, 0 to n-1. So for I is equal to 0 to n minus 1. So this loop is going to count your passes. So you're going to have from 0th pass till n minus 1th pass. Inside this, what should you have? We already told there is a special condition at which we'll stop the sorting. That is, whenever you have one pass in which no swapping is done, you will stop swapping and you will stop sorting. You will consider that it's already sorted. So for that identification, you should have a variable called swapped, which will tell you whether in this particular pass swap happened or not. Okay. So for that, you will have a variable swapped. This variable, let us give a number 0. So whenever you are doing some swap, you should make it 1 so that you identify that in this particular iteration you did at least one swap. Okay. So for that we are having this variable. So we will have the second loop. What should the second loop do? Second loop should go from one side of the array till the point you want to swap. Okay, because in bubble sort we know that after first pass you should not consider last element. After second pass you should not consider last two elements because they are already at the correct positions. So your second loop for j is equal to, let us say it is going from 0 to, till what point should you go? You know the end of the array is n minus 1. N minus 1 is the last element. But when you are swapping, you don't have to go to the last element, because when you are swapping last but one element, you will be considering both the last but one and the last elements, which means you should not go till the last element. So for that you should have one more minus 1. Moreover, as this value of I increases, you should go one element lesser, because one element will be placed at the right position whenever you go through one pass. So in order to counter that, you should have minus I as well. So this will totally count to n minus 2 minus I, that is n minus I minus 2. So your j should go from 0 to n minus I minus 2. So inside this loop, what should you do? You have to compare two adjacent elements and you should swap if it is not in the right position. So if you are going to compare adjacent elements, what are adjacent elements? AR of j plus 1. If your AR of j plus 1 is less than AR of j. So this means whichever is on the right side among these two, the right side element is smaller. So you have to swap these two. So under this condition, what will you do? You will swap AR of j with AR of j plus 1. So you will swap if it is not in the right order. After this, what should you do? You should update this variable so that you know you have done some sort of swapping in this particular pass. So your variable swapped, you will make it 1. So from this variable, you will know that in this pass you did something, some swapping is done. So you need to continue doing sorting operation. So after this, you need to keep a check at the end of this loop. That is, this loop is done, the inner loop. You should keep a check in order to exit from the complete looping in case no swapping was done. So for that, you will keep a check if swapped equal to 0. That means no swapping was done. In that case, what will you do? You will just break and come out. So this is break. So this is your bubble sort algorithm. What does it do? It has n, which is length of array. Then it has an initial loop, which is counting the number of passes that you are doing. Then in each pass, what should you do? You have a variable swapped, which will tell you whether some swap happened in this pass or not. Then you have an inner loop, which will do the swapping. So for this loop should start from the start of the array and go till whichever point you have to go. So in the first time, it will go till the n minus 1th element. Second pass, it will go till the n minus 2th element and so on. So that is why it is n minus I minus 2. In this loop, what will you do? You will swap whenever you find adjacent elements are not in the right positions. And after this, you will update swapped variable, and finally you will have a check. That this check is whether any swap happened in this particular loop or not. If no swap happened, that means complete array is already sorted. So you can break and come out because it's already sorted. So what is the time and space complexity of this? Time complexity here, you took order of n time, and in each of those loops you have an additional order of n time here. So total is order of n into order of n, it will be order of n square. So time complexity of this bubble sort algorithm is order of n square. So order of n square is the worst case time complexity. Even the average case time complexity of bubble sort is also order of n square. But it has a best case time complexity of order of n. That is, if your if your array is already sorted, what happens in the first loop? First pass itself, it will hit this condition, it will come out. So only one time you will have to go through array, which means in best case, it has order of n time complexity, but you are always interested in knowing the worst case, which is order of n square. What about the space complexity? Space complexity is order of 1 because you didn't take any extra space in this algorithm. Yes, you took variables, but that is constant extra space. So space complexity is order of 1. This is an in-place algorithm as well. What is in-place algorithm? In-place means you are not using any extra space. You are doing all the operations inside the given array itself. Moreover, whenever you are talking about sorting algorithms, you have to see whether it is a stable sorting algorithm or unstable sorting algorithm. So in bubble sort algorithm, it is a stable sorting algorithm. Why is it stable? Because whenever you are doing this swapping operation, if two elements are same, let us say this is 10, this is also 10. You will never swap these two elements. So if you have any two elements in the given array which are having same values, you will never exchange their positions, which means whichever came first in the original array will come first in the sorted array as well. So because of this reason, this is a stable sorting algorithm. So this is it about bubble sort.